Hi, my name is Justin Murray, and this is my presentation for Regis University MSDS 696 Practicum 2. In this project, entitled Iron Swami, I tried to predict NFL outcomes using machine learning. In this presentation, we're going to be going over how I collected the data, visualize the data a little bit, go over how I selected my features for my model selection, and the overall outcome of this project. So I wanted to do a quick introduction on football. I will be talking about American football, not soccer. In the game of American football, it's played on a 100-yard field with two 10-yard end zones on each end of the field. Two teams play one another with 11 active players on the field. Each roster consists of 53 players that make up each side's offense, defense, and special team units that take turns on the field. The goal of the game is to move a ball, often called a pigskin, down the field and into your opponent's end zone to score a touchdown. A touchdown is worth 6 points, and a point after attempt, PAT, is worth 1, giving the scoring team a total of 7 points. A score is achieved by moving the ball down the field in a series of plays, also known as downs. The offensive team can move the ball down the field by either passing the ball through the air from a quarterback to a receiver or rushing the ball along the ground with a running back. The offense must move the ball at least 10 yards within 4 plays to keep possession of the ball and earn another 4 downs to drive closer to the opponent's end zone. If the defense prevents the offense from making those 10 yards, the offense has to decide if they want to punt the ball, kick a field goal if they're close enough, or risk giving the opponent better field position and trying to convert on 4th down. After 4 15-minute quarters of play, the team with the most points at the end of regulation wins the game. To start this project off, I couldn't find a data set that contained all the information that I wanted, so I had to resort to web scraping to collect that data. Web scraping is a great alternative when your data set isn't readily available online, and it does open up the data that you can pull in and you can customize what you do bring into your data set. I chose to use Python with the Gazpacho library to scrape data from Pro Football Reference. The cons that I ran into in this project was the website didn't have a consistent format on all of the tables, so I had to do a lot more processing to actually get all the data that I needed for this project. For this project, I wanted to see if I could predict the outcome of a game based on in-game stats like passing yards, rushing yards, penalties, and then the average drive. So I went to Pro Football Reference and I decided that I should scrape the schedule and results page. So I collected the score, offense, defense, and expected points for each team for each season. Now, I didn't think that was enough information, so I did go into each box score of each game to pull out more information. I pulled out some tables that had game information like who won the toss, if they were playing indoors or outdoors or on grass, the duration of the game, the attendance of the game, the weather, the Vegas spread line, and the over and under. And then I also pulled team stats that had a more detailed breakdown of those actual stats within those games. And since I wanted to predict the winner or losers using player stats, I went into the passing, rushing, and receiving tables to pull out the quarterback, 2 running backs, and then 3 wide receivers for each game. So now I just wanted to take you through my web scraping script that I ended up creating with Python and some beautiful soup and gazpacho. Uh, I just had some functions up front to change the team name to abbreviated and back just in case, and then just a list of all the teams that we had. Just a quick overview of I did have a lot of stuff in here. Just pulling all those tables was a intensive process, and all these these functions up top are then to be used in a main function down below to go through each team's year and their whole schedule, and then pull all that information from the box score, uh, team information, game information, all that stuff, and then append that to a data frame, and then save that data frame, and then do that for every single game, and then every single team within that year, and then every single year going back to '02. I did have some issues just because I was spamming their server so much with a lot of requests that I had to throw in some sleeps in between each loop. That did balloon the time to pull all this information. It went from anywhere between 10 hours if I didn't have to request the sleep to 2 runs of almost 24 hours. But I did end up pulling 18 years worth of games of every single team's schedule. And then after I got all that information, I decided that I wanted to focus on the home scores just because I'm going to have duplicates of everything that's going into this data frame. And I didn't want to have a bunch of duplicates for the machine learning down the road to get trained on or to get tested on. So I did end up removing half the data just because that was away games for half the teams. So I wanted to do a quick EDA on the data that I just collected. I ended up smashing the two data frames that I had, the 2002 to 2010 and then 2010 to 2019-2018 season. And then I removed those duplicates from the 2010 season. But this is just a quick graph of the team's home wins per season. I didn't divide them up into the division, but it's just randomly divided up alphabetically from team name. So you can see just how some of the teams did. The Chicago Bears didn't really do too good from 2014 to 2017, and then had a little rise when they got Khalil Mack. And then just some other teams. We got the Denver Broncos in here, having a high season in 2012, and then a fall off once they lost Peyton Manning. So you can see some trends in some of the teams that they go up and down. I did find some issues with the Seahawks. They, for some reason, they didn't have too many uh, wins or entries in my data set. I think they ended up getting dropped out due to nulls. So there are some inconsistencies with some of these graphs. But over here you can see that over the dynasty, the Patriots just have a nice steady record of 9 to 10 home wins per season. After this, I just wanted to go into some of the Vegas stuff that I was going to ultimately get into, but didn't because I ran into some issues that we'll talk about in a second. But this is just a graph of the home underdogs per season. It looks like there are anywhere between 3 and 4 teams that do have some that are home underdogs. And then the spread distribution is right around 7.5. So Vegas usually does do a 7.5 or 6.5 just to get rid of some of the pushes at 7. So that does make sense that a lot of the stats are right around, the spread is right around 7. I want to do a little box plot of the spread. There are a bunch of outliers that the spread was up in 20, but it does seem consistent at around 7 to 3, and that does align with how Vegas does set those spreads. And then the home and away scores do match pretty consistently, so there isn't a big differential between home score and away score, so these games usually are tight. I wanted to jump into a heat graph, but since my data frame was extremely large, I ended up getting this. It's a bunch of um, all my columns. There are little pockets of high correlation and no correlation just everywhere within here. I do have a graph that we can go through if you want to look at this in a little bit. And then I started to do some pre-processing to see how I wanted to go about predicting and which models I wanted to use. And this is where I ran into my first really huge issue. When I thought about it a little bit, I would be training my model on data after the game was completed. And if I wanted to predict the winners and losers, I would not know all those game stats that I pulled. I wouldn't know the away total yards, um, the home score, away score. So everything that I pulled was basically unusable. So I did decide to switch up a little bit and use the data that I already used or already gathered and change it into a rolling means of the previous four games so I could have that information before the game so I could try to predict the winners and losers. So quickly to go through this rolling mean that I created, it does go through every single column and determine if the team is home or away, and then uses the previous four in that column to create a rolling mean. I did have to do this for each home and away team to complete my data frame, and this is what it turns out to in the very end. So it's nicely, it has the opponent, the actual home team, the year, and then these first couple games, just the first couple, are getting dropped out just because they're nans and they're not a part of that rolling mean. After that, we are ready to go into some models and trying to predict who's going to win a game. I did end up using three different models to compare and contrast which one would perform better. I started out with a neural network with three hidden layers using the activation of Ryu. They were all dense layers, and then the last one I used a sigmoid activation to determine if it was going to be a 1 or 0, a win or a loss. And that did decently well. I wasn't proud of it. It ended up coming out with an accuracy of 55% with a loss of 0.6867. This would win money in Vegas if you consistently betted on a money line of negative 110. To be consistent at beating money lines at 110, I think you have to be around a 52% chance of winning. This would go up to a negative 125 money line. So it is possible to win money from Vegas if you bet on the correct games with this neural network. So after the neural network, I decided to move on to a random forest model to see if that did any better. It did about the same. It wasn't anything to brag about. It was still around 55%. It would creep up to like 56%, depending on the random seed that we got. So that model also had some room for improvement. After that, I jumped into a support vector machine (SVM), and that did a little bit better. It was pushing 60. It was around 58, 59%, which is doing a lot better. Um, More comfortable using that one to wager some money, but there is still some room for an improvement. I would like to still modify some of these features that we used. I don't think using player stats is the most consistent and most reliable thing to do. I think it would have been a better outcome if I would have used some of the ranking stats that were available and pull in some team rankings and power rankings from ESPN and some other sources to try to rate the teams a little bit better, but there's always room for improvement. And I learned a lot throughout this whole process, and I had a great time doing it. My code is available at github.com/jmurray305. That's JMURRAY 305/Swami. If you want to check out my code or leave some comments, please feel free to. Thank you and have a good day.